Hello, my name is Delfino.
Hello, it's me, Cynthia.
And we have some questions for you. Do you think that all the brains work in the same way?
Have you ever analyzed how humans learn another language?
Have you ever wondered how the human brain system works? Let me explain you a little bit about it. The human nervous system has 4 components. 1, brain. 2, spinal cord. 3, nerves. And 4, sense organs. The first one and the second one, the brain and the spinal cord, created what is called central nervous system, CNS. Around these 2 important parts of the brain is something called the peripheral nervous system that transmit impulses. These impulses goes to the nerves. The nerves are a collection of neurons that transmit every message to the world, to the whole body, right? Second, the human brain or the human system has 3 functions. 1, regulation, that control energy levels of when everybody makes an activity. This is what regulates the energy. Second one, processing, and third one, formulation. In processing, it analyzes, it codes, and it stores the information in the brain. And formulation is responsible for the formation of intention in every action that happens or human being makes. That's it.
What can you tell us about the model's linguistic processing?
Well, this model varies depending on the task and the individual language. The way information is processed represents the voluntary problem solving strategy of each person. And this is information processing, which is divided in 3 different processes. We have attention and discrimination, organization, and memory and transfer. And the attention and discrimination includes awareness of a learning situation and active cognitive process. Also, this one is divided in 3 sections, that is orientation, reaction, and discrimination. In the orientation, we can say that there is the ability of sustain attention over the time. In the reaction, this refers to the amount of time required for an individual to respond to a stimulus. So it means that every single person is going to react different to an action. And in the discrimination, it is the ability to identify stimuli differing along some dimensions. So if it's not important for them, it will be discriminated. In the organization, it is theorized that memory capacity is fit and better memory results from better organization. So in this one we have the medicinal and the associative. In the medicinal, it means that a symbol can link some information. For example, if we see an image of an image, it will facilitate to link to another situation. And one symbol is linked to another one. In the memory, it is the sensory information storage, working memory, and long-term memory. So all the information that we have, we keep it memorized in the long-term memory. Is best when info is deep processed. It includes semantic interpretation and elaboration. The learning is facilitated by relating it to experience and knowledge. So at the moment that you learn something or you want to learn, you have to relate it to previous knowledge so it can be deeply the learning and it's gonna be easier. An example for this, it can be the names. Some people struggle learning names, for example the teachers. We can say that if you relate the name of the student with somebody that you know, it's gonna be easier to learn that knowledge or that process. Every stimulus has both a sensory impression or a signal. The signal is meaningful but not linguistic. Example, the sound of a car. If we hear the sound of a car, we can infer, we can make the relation to a car or to a truck. In the contrast, the abstract representation or word linguistic in nature. In the echoic memory is the ability to remember what is heard but when it's no longer present. For this one, we can say that if you hear far away the sound of a bell, for sure we know that it is a bell, and we can make the relation to a church. So actually we don't need to see the object, we can make the relation. In the transfer, the ability to apply previous learned material in solving similar but novel problems. The greater the similarity, the greater the transfer. When the two are very similar, it is called near transfer. When it is dissimilar, it is far transfer.
Topic, there are some other cases very important for learning. In this case, we can see here the other processing, which is called top-down, bottom-up, passive-active, serial and parallel process. All of those are very important because they have like another branches coming out of those. So for example, top-down, it's going to differ in the input of the person. For example, we have here the example mentioning the sentence, the cat, cow, you instantly listen to that sentence and you are thinking about maybe a moose or a mice. So this is like part of the brain, it's already working. We are like unconscious because you are not telling what is next. So your brain is automatically thinking about the next word. And this is a very common example. And this is a conceptually driven. So in contrast, we have bottom-up process, and this is a data-driven. This is it's an analysis that occurs of the level of sound of a syllable. For example, we have here the word moose, and you have this part of the phoneme level with the little u. So this is a kind of analysis, but the two processes, top-down and bottom-out, occur simultaneously and can be used in processing of tasks. So the next one, we have passive, active. Maybe you have an idea about what is passive and what is active just for those words, but they're based of recognition patterns or information. And passive process, we have an analysis in fragments. That means that it can be combined in individual or to recognize a pattern. That means that the method is similar to a bottom-up, what we have here. Okay, so active, right here, involves the using of a strategy. And they were acknowledged on a basic, this model we have here from the gradually active engagement with environment. So here the environment is very important for make a sense as the reading said of the word. So we have the next one. Two processes are also simultaneously, both top-down and passive-active. The next one we have here also serial and parallel process. So serial we have is a consequent. Serial is like the word said, it's continuous. So in this part we have here processes. We say it like one at the time of nature because this is located in the left frontal and temporal lobes. So we can find this and those parts of the brain. And well, other example, we come the frequency, the intensity and duration of the synthesis to determine a phonetic feature. And parallel, this part we have here, parallel process, is access multiples and levels of analysis. We're in the lecture set apart, it's multiple levels on analysis at the same time, located in the occipital and parietal, those areas. We have two areas for serial, and we have 2 areas for parallel. So we know that serial it's in the left part, and parallel we have it in the occipital. So this is related with. In practice, those processes occurs together. Maybe I don't know if it's in the same time, but they occur. They going like joining, and also it's more processive of the brain. Well, so those parts are like very very important for the function of the brain when we are learning. We are focusing in some syllables. We are focusing in others. You can find the parts of those characteristics in different parts of the brain. So let's go with the next one.
In conclusion, we can tell you that every brain works in a different way. Actually, there is not something clear about it, but we as teachers, we can see that every student has a different process and they learn at different time.
Exactly. And you can see in the world there are many theories about how the human brain works for learning. So we can experiment that through the profession we are still working on. I am a teacher and Chloe is also a teacher. We can see that through all the students, and also Delfino is a teacher. But we have different point of views according to the learning in kids, in adults, and even in people who maybe they have more age. So it's totally different. We have a little about this, and we're so proud to still fit this knowledge that we are gonna leave this moment for Delfino. He's introducing a very interesting quote.
To sum up this presentation, I am going to quote a thought of Werber and Gleitman that said that the development process of the brain function is called enigmatic, mysterious. There is no explanation of how the brain works. For every person is a very different matter, and so we can conclude that we as a teacher have to be very sensitive, detecting how one person works, another person works, because we are human beings and we are different. So I think that's it.